Ladies and gentlemen, welcome to week 4, in which we take a look at advanced business process modeling. This week is organized in 6 video clips. In the first one, we take a look at sub-processes. Video clip 4.2 looks at sub-processes and boundary events, so we can attach specific kinds of events to activities, also to sub-processes. And we discuss this in 4.2. 4.3 looks at activity modifiers. In 4.4 we take a look at racing events. So there are events, several events of a business process model can race against each other so that only one can win in this race, and we discuss this in 4.4. Video clip 4.5 looks at organization, how to represent organization, and 4.6 takes a look at resource allocation patterns. So how can we allocate resources to activities in business processes? Regarding the notation categories and their elements, so this week we take a look at activities, specific kind of activities, complex activities as we learn. We take a look at events, and also regarding the organizational aspects, we take a look at pools and lanes, so pools and swim lanes in BPMN. But let's start with sub-processes. We covered in week 2 already activities, but there we only discovered activities that do not have an internal structure, so atomic activities, or task are they called in BPMN. And of course we also covered sequence flow, gateways, uncontrolled flow, and a number of events. And we discussed that using application scenario of the order fulfillment process. And you see that even our example process here gets a bit complex already. Well, not too complex, but you will see in your organization when you model processes, they can easily become quite complex. And therefore we want to introduce a modeling guideline, and that is the size, regarding the size of process models. So each process model shall fit on one page, one normal sized page, and it should be readable on that page. And well, the motivation is that process models provide or should provide a common understanding only if they are understood by all stakeholders. So they can provide this common understanding only if they are understood by all stakeholders. And process models with hundreds of elements are really not very good understandable, or almost incomprehensible. Therefore, there are different means in BPMN to handle this complexity, to deal with this complexity on the model level. And the first thing is we can split large process models up by link events. So if a process model does not fit on a page, reasonable space, it can be split and distributed over several pages. And these link events cut sequence flow. So we can use the link events. If we have a large process, we can cut a sequence flow in one position and then separate this, or allow the connecting of these two parts again by the link events. Here we see an example of a link event, and that is we have here, so the first part of the process where we check the order for correctness until the order is verified. We can cut the process here, and we also need to use a meaningful label here, so that is a state that the process has reached. And here the label is order verified, so at that point in time the order that I received, that I checked, is at that point verified. And then we have another intermediate event that triggers, or that represents the start or the continuation of that process in a different sheet of paper, for instance. Well, that's the same label, so these two identical labels represent that they are really identical, or that the link should be provided there. And there the process continues just normally. Link events cut sequence flow. We have only intermediate link events, since they are not the begin and the end of the process, but they are in the middle of the process. And thereby we have the funny situation that we have intermediate events that do not have an outgoing edge. So here, the one on the left-hand side, or the throwing intermediate event, that does not have an outgoing edge, and the catching intermediate event on the right-hand side does not have an incoming sequence floor. Normally, intermediate events have both incoming and outgoing edge, therefore they are intermediate. But in this case, no. That's a nice. That's a question that we here and there ask our students. Anyway. All right, so that's the first way how to structure this, how to cut processes, and then make sure that the process then is able to be split on several pages, for instance. But that does not really lead to a better understandability, because even then you have this very large flat process model, and that is spread over a number of sheets, so that not in all cases is really what you like to see. Therefore, BPMN proposes or provides sub-processes. These are specific activities that have an internal structure. So there are two types of activities. There are tasks that are atomic units of work. They do not have an internal structure. And there are sub-processes. And sub-processes internally have activities with an internal structure, an internal process structure. So sub-processes can contain other processes as well. Therefore, sub-processes provide a hierarchical decomposition, and that's very useful for coping with complexity. So we see that in other types of models where you have modules, and modules can be contained within other modules, and that provides a hierarchical decomposition, a tree-like decomposition of a complex model, of a complex entity in general. Sub-processes can be collapsed. In that case, the internal structure of the sub-process is completely hidden, so we can also use that for abstraction. So regardless what's inside of the process, I use that as one activity in a process. And the collapsed sub-process references another process model. And here, these cannot be multiple references, and we will come to call activities in a minute, where we can have really multiple reference to a given process. And the collapsed sub-process is represented by here. So by the label of the sub-process and by this marker, and that is this plus sign in the lower middle part. There's a plus sign. And but other than that, you can use this sub-process really in one business process, and then you hide all aspects that are internally to that process model. On this slide, I like to discuss a little bit the hierarchical decomposition feature. And therefore, I use the pen. I have a little example here where we do have a process that has one activity A and activity B. I need to do that plus. This is our process, and then we have an activity C, and then it stops. So there's the end. So that's how we can use sub-processes also as normal activities instead of the sub-process marker. And that shows that there is an internal structure of process B. And process B might look like this. So I use consistent labeling. So the sub-process of B, our sub-activity of B is B1. And then we can have, for instance, any process structure that we desire. That's B2. That's B3. B3, hope you can read it, can also be a sub-process, and then it continues off. And that is inside of these B. So if you, depending on the tool, if you click on the sub-process, a new canvas opens where you see then the internal structure of the process B. And of course, the process B can have this internal process structure and can also include other sub-processes. So here we have B3 as a sub-process that might contain B31 and B32. Okay, and that is underneath here. Yeah? So that's a sketch on how this hierarchical decomposition is. We can also use a tree-like representation. So let's consider this is process P, and this is process B, and this is B3. Then we can come up with the following tree structure. So on the root of the tree is a process P. Process P contains activities A, B, and C. I disregard the events here. That's a containment relationship. A is a task, so there is no internal structure. C is a task as well, but B has an internal structure, and B has sub-activities B1, B2, and B3. And B3 also has sub-activities B31 and B32. So this gives you an idea of the hierarchical decomposition of a process into sub-processes until we came to a point where we only have tasks left. All right, so we looked at the collapsed sub-process in the previous example where there is a plus in the shape, or there's a marker, the plus marker in the shape of the activity. But we can have another representation of sub-processes, and these are the expanded sub-processes. Expanded sub-processes provide a means for specifying parts of a process that logically belong together. And expanded sub-processes do not hide their structure, but they expose their structure while they are used. So we see it here. So we have here an example of an expanded sub-process. We can have, again, activity A, then we can have something like this, and then C, and so forth. So we can also use this expanded sub-process to show the internal structure if that's useful from the modeling perspective. We like to illustrate the concept of sub-process in our application scenario. Here we have a part of the order process we've been looking at before, and here we see the upper part. We have structure like this. So, well, and that somehow logically we can say that this somehow logically belong together. That's the obtainment, that's the procurement of the parts from the two suppliers in this inclusive OR structure. And regarding the modeling goal, the suppliers and the way the material is obtained might not be relevant. So if this part is not relevant for the process at hand, for the discussion at hand, then we can hide this in a sub-process. All right, so if it's not relevant, we can hide this in a sub-process. However, in the process model, the activities are represented at this point in time, and they add complexity, and we want to get rid of this complexity, and of course we can use sub-process for achieving that. All right, and the idea is exactly what I discussed before, and so there is this structure, and the structure adds complexity. We want to reduce complexity in the number of nodes of this process model graph, so in the number of activities, and also in the number of gateways. And we can do that by just hiding the complexity in this process. Sorry, I need to again do the highlighter. I hide this in the obtain material sub-process. So actually what happens is that this structure consisting of 4 activities, 2 gateways, and a number of sequence flow edges. We can hide all this structure in the sub-process, in the collapsed sub-process here. And thereby we still have let's say, first of all, we have reduced the complexity of the model, and we still carry the information. We still carry the information that at that point in time, we need to obtain material, and then afterwards we can manufacture the product. So the process logic is still there, but it's not represented in an as detailed way as before. We can also use expanded sub-processes to indicate that there is a part of the process that logically belongs together. And we'll do that here. So here in the first view, it's clear that this structure logically belongs together, and it even got a name. So the obtained material, this has a specific name. The sub-process needs a specific name, and that's of course the same name as we have here. And that gives you an idea about, well, parts of the process that logically belong together. However, it does not really add to abstraction, to simplification, to hiding complexity. In fact, it's in terms of structure, it's even a bit more complex than it was before, but still it gives a visual impression of parts that logically belong together. All right, let's talk a little bit about subprocesses and abstraction. So first of all, we started out with a detail or so-called flat process model. It does not have the hierarchical structure, therefore we can call it a flat process model. And that what we've seen here. We can have expanded subprocesses that provide a logical grouping of activities or parts of the process that logically belong together. And we can have a collapsed subprocess that provides a hierarchical decomposition and that really hides the complexity. So in terms of abstraction, the collapsed subprocess provides the strongest means to come up with, to provide abstraction. And that's what we initially talked about. When our process models grow too large, we can identify parts that belong together and hide these as subprocess, and we can then collapse it to reduce the complexity of the process model and to provide abstraction. That brings us to the end of video clip 4.1, in which we discussed subprocesses. We talked about collapsed subprocesses that provide hierarchical decomposition of complex process models, also information hiding to reduce complexity. But we also talked about expanded subprocesses that provide a logical grouping of parts of process models.